Beyond Saturn's pale rings, the solar system begins to lose its warmth. The sunlight here is weaker, like a memory of fire. The planets no longer shine by reflected brilliance. They glimmer faintly, swallowed by distance. And still, Voyager moves forward. Not because it must, because it was told to. Because curiosity is written into its very code, the same way it's written into ours. The Great Silence. For months, then years, Earth hears only whispers, binary pulses echoing across billions of kilometers. The Voyagers are tiny, but their voices are steady. Packets of data, compressed light, telling stories of dust, wind, and radiation. By now, it takes nearly 8 hours for a signal to travel one way between Voyager and Earth. A single command becomes a conversation spread over 16 hours. And yet, communication never falters. Through the Deep Space Network, 3 massive radio antenna arrays scattered across the world, Earth still listens. Australia, California, Spain, 3 ears turn toward forever. Voyager 2's path to Uranus. It is 1986. A decade has passed since the launch. The world has changed. New wars, new technologies, new generations. But somewhere beyond Saturn, Voyager 2 prepares for a meeting no human has ever witnessed. Uranus, the first planet discovered by telescope, now about to reveal its true face. Uranus is distant, tilted, and strange, a planet that spins sideways as though it once collided with a ghost. It's a world of cold, turquoise light circling the sun once every 84 years. When Voyager 2 finally arrives, the images that stream back are haunting. Uranus is smooth, almost featureless, a blue-green sphere wrapped in clouds of methane. Yet beneath its calm lies violence. Winds here howl at 900 kilometers per hour. Temperatures plunge below -220 degrees Celsius. The rings, thin, dark, and ghost-like, circle in silence, nearly invisible until sunlight catches them like dust on glass. And around it, a family of 27 moons drift in slow motion. Some cratered, some fractured, all ancient. Miranda, the broken moon. One moon stands out, Miranda. When Voyager's cameras captured its surface, scientists at first thought the data was corrupted. Miranda looked impossible. It was a patchwork of canyons, cliffs, and mismatched terrain, like a world shattered and stitched back together by unseen hands. Faults running hundreds of kilometers. Cliffs 20 times higher than the Grand Canyon. A world rebuilt after catastrophe. No theory could fully explain it. Perhaps Miranda had been torn apart by Uranus's gravity, only to reform again. Perhaps it was sculpted by ancient cryovolcanoes. Volcanism made of ice instead of fire. Whatever the truth, it stood as a reminder, even in desolation, creation persists. The pale turquoise giant. Uranus didn't roar like Jupiter or burn like Venus. It whispered. Its magnetic field was tilted wildly, misaligned from its axis, dancing in unpredictable spirals. The planet's seasons lasted decades, each pole facing the sun for 40 years at a time. Voyager 2, like a patient visitor, mapped its shape, measured its winds, counted its moons, and then, quietly, moved on. It had one last appointment with the farthest giant of them all. Neptune, the Dark Symphony. Voyager 2 approaches Neptune, the last known planet. It is nearly 4.5 billion kilometers from the Sun. From Earth, Neptune looks like a soft blue dot. Up close, it is something else entirely. A world of cobalt storms, raging faster than any winds in the solar system. Voyager's cameras record the Great Dark Spot, a hurricane large enough to swallow Earth, roaring through methane clouds at 2,000 kilometers per hour. Lightning flashes beneath a sea of blue. Methane crystals swirl like powdered diamonds. The planet hums with energy no one expected, heat radiating from deep within, as though Neptune's heart refuses to die. Triton, the frozen moon. Then there is Triton, Neptune's largest moon, and one of the strangest. Voyager's instruments detect geysers, jets of nitrogen gas erupting from beneath a pink-white crust of frozen methane. Triton is alive, though barely, a cryovolcanic world orbiting backward against Neptune's spin. Its surface glows faintly in reflected light, etched with patterns like coral reefs and dunes sculpted by invisible winds. Scientists realize something astonishing. Triton may once have been a wandering world, captured by Neptune's gravity long ago, a stolen moon pulled into orbit from the deep beyond. The last look back. As Voyager 2 drifts away from Neptune, its cameras turn once more toward home. In a single image, the sun becomes a brilliant white spark. Around it, every planet, every world we know, fits into a handful of pixels. It is a family portrait of the solar system, the last ever taken by humanity's first true explorers of the deep. Voyager 2's work among the planets is complete. There will be no more flybys, no more worlds to photograph. From here on, there is only distance, and the quiet hum of data continuing into eternity. Crossing the outer frontier. Beyond Neptune lies a vast region called the heliosphere, a bubble of solar wind extending billions of kilometers in every direction. It is our sun's invisible shield, protecting the planets from the raw radiation of interstellar space. Within it, charged particles flow outward, constant, invisible, a whisper of the sun's breath. But at some point, that wind stops. At some unseen frontier, it meets the pressure of the galaxy itself. This is the heliopause, the true edge of the solar system. No spacecraft has ever crossed it. Voyager will be the first. The interstellar highway. To reach it will take decades. Voyager must travel at 17 kilometers per second, fast enough to cross the United States in 4 minutes, yet slow compared to the scale of eternity. By 1990, the data rate has dropped to a trickle. Each image, each byte of information takes hours to send. And still, the spacecraft endures. Systems rerouted, instruments recalibrated. Its mind grows dimmer, but not silent. Then, one last task before the long sleep. The pale blue dot. On Valentine's Day 1990, at Carl Sagan's urging, Voyager 1 turns its camera around, back toward Earth. From 6 billion kilometers away, it captures a single frame of scattered sunlight. A shaft of color, refracted through the camera optics, cuts across the darkness. And in that shaft, a tiny pale speck, less than a pixel wide. That's us. Every human who ever lived. Every war, every invention, every dream. All contained in that single point of light, suspended in the cosmic night. Sagan would later write, "Look again at that dot. That's here. That's home. That's us." It was not just a photograph. It was a revelation. A fading light. After the portrait, Voyager's cameras are turned off forever to save power. But its other instruments continue their quiet vigil. For the next 20 years, the Voyagers drift through the sun's vast outer shell, measuring radiation, cosmic rays, and magnetic fields. Every reading is a clue, every anomaly a story. They detect waves of plasma rippling through the heliosheath, bursts of charged particles from solar storms, fluctuations in temperature that hint at the approaching boundary. The data is scant but precious, messages from a frontier no human hand will ever touch. The edge approaches. The sun's influence weakens. Solar wind slows, pressured by the interstellar medium ahead. The density of charged particles increases. Magnetic fields twist and ripple. Voyager's instruments begin to sense something strange, an energy that doesn't belong to the solar system. And then, one day, it happens. The solar wind fades to zero. The galactic breeze takes over. Voyager 1 has crossed the heliopause. For the first time in history, a human creation has entered interstellar space. It is August 25, 2012. The signal arrives at Earth 17 hours later.
The numbers are quiet, unassuming, but behind them lies the truth. Voyager 1 has gone where no voice from Earth has ever gone before. It has touched the dark between the stars.
In the endless silence of space, there drifts a tiny spark of metal and memory. A messenger from a world of oceans and wind, sent to speak for us when we are no longer here. Its name, Voyager. 2 of them, born of fire and ambition, flung into the heavens in 1977, when humanity still wondered if the stars were listening. We did not know then that these machines would outlive empires, outlast generations, and one day pierce the very edge of the sun's dominion. We only knew this: the sky was calling, and we had learned how to answer. The dream of departure. The 1970s were a quiet turning point. The moon had been conquered, Earth photographed in its entirety. But curiosity is a hunger that no achievement can feed. Far beyond the moon, 4 giant worlds waited: Jupiter, Saturn, Uranus, Neptune, lined up in a rare cosmic alignment that happens once every 176 years. An open window through which a single spacecraft could visit them all, using their gravity as slingshots from one to the next. NASA called it the Grand Tour. To dreamers, it was a voyage through time itself. And so, engineers in Pasadena began to design what would become the most remarkable pair of explorers ever built. The making of immortality. Voyager 1 and Voyager 2 were not majestic to look at. Each was a fragile skeleton of aluminum, titanium, and gold, barely the size of a small car. But within that frail frame pulsed the most advanced heart humanity could craft. Cameras that could see 1 billion miles away, sensors that could taste invisible radiation, and a tiny nuclear furnace, plutonium-238, warming them through the cold forever. On one side, a great golden dish, their voice and their ear. On the other, bolted carefully, a 12-inch record made of gold, engraved with sounds and pictures of Earth, our music, our greetings, our dreams. A message in a bottle, cast into an infinite sea. Carl Sagan called it a gift from a small, distant world. A hope that if someone, somewhere, should ever find these wanderers, they might know that we once lived and we cared to understand. Countdown to eternity. Cape Canaveral, 1977. The air trembles with hydrogen and flame. First, Voyager 2, August 20th. Then Voyager 1, September 5th. Twin pillars of fire carve the dawn, carrying our voices into the unknown. As the boosters fall away, the Voyagers awaken to a view no human eye has ever seen. Earth shrinking to a pale blue marble, framed in sunlight, fading fast. They are alone now, 2 artificial minds following a script of gravity written by ancient physics. Yet from the moment they left, they were watched by every soul who still believed in discovery. Crossing the orbit of Mars. Months turn to years. Radio signals stretch thin, each message taking longer to return. Through antennas the size of buildings, Earth whispers commands across the void. Turn this way. Open the camera. Listen. The Voyagers obey. Their first destination, Jupiter, the king of planets. It looms ahead like a world on fire, larger than all the rest combined, its storms older than our species. Arrival at the giant. In 1979, after a journey of 640 million kilometers, Voyager 1 approaches Jupiter. Its cameras open, and the solar system is never the same again. Before that moment, Jupiter was a smear through telescopes, a swirling blur of orange and white. Voyager's images revealed an entire planet alive with motion. Storms the size of Earth spinning in eternal fury. Lightning arcs stretching thousands of kilometers. Cloud bands twisting like living muscle. Scientists stared in awe. This wasn't just weather, it was architecture, an atmosphere sculpted by physics into beauty. And then came the moons.
The moons of mystery. Voyager 1 turned its gaze to Io, Jupiter's volcanic moon. No one expected what came next. Where scientists imagined a frozen rock, they found a world on fire. Mountains spewed sulfur hundreds of kilometers into space. Lava flowed like rivers of gold beneath a sky of ash. It was the first active volcano seen beyond Earth, proof that even in the outer darkness, worlds can burn with energy. Then Europa, a moon of ice so smooth it seemed carved by intention. Beneath that crust, Voyager's instruments hinted might lie a hidden ocean, a sea beneath a shell of frozen light. An ocean that could shelter life. For the first time, the question of "are we alone?" felt less like speculation and more like an invitation. A world of storms. Voyager 2 followed months later, tracing the same path, confirming and expanding what its twin had seen. It mapped Jupiter's faint rings, discovered new moons, and revealed auroras that danced like fire at the poles. The data poured in. Magnetic fields, charged particles, radiation belts so intense they could erase memory from a computer. Jupiter was not merely a planet, it was a miniature solar system, a gatekeeper shaping the orbits of everything that followed. And as the Voyagers departed, Jupiter flung them outward, deeper into the dark. The gravity assist worked perfectly, slinging Voyager 1 towards Saturn and Voyager 2 on a longer path that would one day reach Uranus and Neptune. Saturn, the ringed enigma. Voyager 1 crosses 1.5 billion kilometers from the Sun. Ahead lies Saturn, pale gold, serene, distant. Through its lens, the rings resolve not as solid bands, but as countless particles, ice and dust, each reflecting sunlight like mirrors. They span hundreds of thousands of kilometers, yet are thinner than a page. Between them lie moons like pearls. Titan shrouded in orange haze. Mimas scarred with a single vast crater. Enceladus bright and reflective, a clue to hidden heat within. Voyager 1 dives through the plane of the rings, capturing sunlight scattering across billions of icy fragments, a cosmic snowfall frozen in motion. Titan, the orange mystery. Among all the moons, Titan was the prize. Bigger than Mercury, wrapped in a thick nitrogen atmosphere, it was the only moon known to possess weather, rain, clouds, wind. Voyager 1's instruments strained to see through the haze, but found only mystery. What lay beneath those clouds? Lakes? Rocks? An ocean of methane? No one knew. But the data hinted at chemistry resembling that of Earth, where life itself may have begun. Titan became a symbol of potential, a place where evolution might have written a different story. A decision in the dark. After Saturn, Voyager 1's path carried it upward and away from the solar system's plane, never to encounter another planet. Voyager 2, meanwhile, was aimed downward, on course for Uranus and Neptune. The dream of two explorers diverging into eternity. Back on Earth, the engineers knew they would never touch these spacecraft again. The power of the plutonium cores would fade slowly, decade by decade. The cameras would eventually go dark. And yet, the mission was far from over. Voyager had shown us a solar system alive with possibility, more dynamic and diverse than we'd ever imagined. But beyond Saturn's rings lie a deeper frontier, a boundary where the sun's breath meets the interstellar wind, a place where the solar system ends and the galaxy begins. As the Voyagers sail onward, the light of the sun weakens. Its warmth fades into nothing. The stars grow sharper, colder. Ahead lies the unknown, a region called the heliosphere, the vast bubble inflated by the sun's invisible wind. Beyond it, true interstellar space. No human or machine has ever crossed it. Until now.
The sun is now just another star in the distance. Its warmth long gone. Its gravity fading. And yet, something continues forward. A golden machine, no larger than a piano, built by hands that will soon return to dust. Voyager has crossed the frontier. The solar system lies behind it. Ahead, infinity. But what does infinity sound like? The first breath of interstellar space. When Voyager 1 entered interstellar space in 2012, its instruments registered something no one had ever heard before. A faint vibration, a whispering hum. Not noise, but music. Plasma waves rippling through the interstellar medium. Out here, there is no space as we imagine it. Even between the stars, the void is not empty. It's filled with a thin ocean of charged particles, hydrogen atoms stripped bare by cosmic rays, drifting in a cold, eternal wind. Voyager's plasma detector, silent for years, suddenly came alive. It measured vibrations in that interstellar sea, waves resonating at frequencies so low they could be converted into sound. Scientists did exactly that, and what they heard was haunting. A ghostly, trembling tone, the voice of the galaxy itself. It was proof that Voyager had truly left the sun's realm, proof that even in darkness, the universe sings. The galactic ocean. Imagine standing at the shore of an endless ocean. Behind you, the land of your birth. Before you, the abyss. That's what Voyager has done. It has reached the edge of the sun's magnetic bubble, where solar wind collides with interstellar gas. The boundary isn't a wall. It's a turbulent frontier, a shifting sea of particles, waves, and invisible currents. Here, magnetic fields twist and fold, charged ions collide, and galactic radiation flows freely from every direction. For the first time, we can measure it, not through theory, but through experience. Voyager is humanity's first taste of the interstellar medium, a realm between the stars, filled with history older than the sun. Each particle it detects may have drifted for millions of years, born in the hearts of supernova, carried across the Milky Way like dust on a cosmic wind. Voyager 2 follows. 6 years later, in 2018, Voyager 2 crossed the same boundary. Its instruments confirmed what its twin had found, a region dense with cosmic radiation, silent to solar winds, alive with galactic energy. For scientists, it was a triumph. Two independent witnesses, separated by billions of kilometers, confirming humanity's passage into interstellar space. The data revealed that the heliopause isn't smooth. It ripples, flexes, and breathes with solar activity. When the sun flares, the wavefront expands. When the solar wind weakens, the frontier collapses inward. The border between stars and sun is not static. It is alive. And Voyager is sailing through it. The fading voice. By now, the Voyagers are over 23 billion kilometers away. Their signals are unimaginably faint, 1 trillion times weaker than a cell phone's. And yet, Earth still listens. Every whisper they send takes more than 22 hours to arrive. A beam of light carrying data from a distant world, caught by dishes the size of buildings, amplified, decoded, and transformed into knowledge. The two spacecraft now drift through the deep night, their power fading with each passing year. The plutonium in their cores decays slowly, releasing less and less warmth. Subsystems are shut down one by one. The cameras have long gone dark. The gyroscopes rest. Even the heaters silence to conserve energy. And yet, the transmitters still live. Voyager speaks in a language of ones and zeros to a planet it will never see again. The cosmic ray frontier. Out here, Voyager senses a storm of invisible bullets, cosmic rays, high-energy particles born in distant supernovae. They pierce its instruments constantly, creating faint flickers of static. On Earth, we are shielded from most of them by the sun's magnetic field. But beyond the heliopause, Voyager faces the true radiation of the galaxy. These measurements help scientists understand not just the solar system's edge,
but the galaxy's invisible anatomy, its magnetic scaffolding, its radiation belts, its hidden storms. In a sense, Voyager has become a weather station for the cosmos. The interstellar message. Both Voyagers still carry something extraordinary: the golden record. A 12-inch gold-plated copper disc, etched with sounds and images of Earth. Greetings in 55 languages. The laughter of a baby, the roar of thunder, the heartbeat of a mother, and the music of Bach, Beethoven, Blind Willie Johnson. Etched in gold, it spins silently in the void. Somewhere, billions of years from now, it may be all that remains of our civilization. If another intelligence ever finds it, it will tell them that in this corner of the galaxy, there once lived a species that longed to know, and that we once reached for the stars, not with weapons or conquest, but with curiosity. The silence ahead. There will come a day, soon, when the Voyagers fall silent. Their power will run out. Their voices will fade. By 2030, perhaps 2035, the last transmitter will shut down. No more data, no more heartbeat. Only motion, endless, patient, eternal. They will continue coasting at 17 kilometers per second, orbiting the galaxy every 225 million years, carried by gravitational tides among the stars. Long after the continents shift, long after the oceans evaporate, long after the sun itself has burned out, the Voyagers will still be there. Two artifacts of a long-forgotten species, adrift in the galactic dark. The reflection. When Voyager turned its camera toward Earth in 1990, it gave us more than a picture. It gave us perspective. That pale blue dot became a mirror, reflecting our fragility and our unity. And now, as it drifts into forever, Voyager gives us another kind of gift, a lesson in endurance. That curiosity is stronger than time, that exploration is our nature, and that meaning is not something we find in the stars, but something we bring with us. Because Voyager is not just a machine. It is us, the human spirit, encoded in metal and motion, defying entropy for as long as the laws of physics allow. Legacy. When the last signal fades, there will be silence, but not absence. Voyager will continue to exist, not in communication, but in symbol. It will be a relic drifting through eternity, a time capsule from a species that once dared to imagine beyond its sky. Somewhere, billions of years hence, long after Earth has been swallowed by the dying sun, Voyager will still circle the galaxy, perhaps passing near another star, its golden record intact. Maybe no one will ever find it. Maybe that's not the point. Maybe Voyager's purpose was never to be found, but simply to go. To prove that intelligence can reach beyond its cradle, that life can dream beyond survival, that we, for a brief moment in cosmic history, became aware of the infinite. And so, in the deep between stars, two tiny messengers drift endlessly. Their systems dim, their energy fades, but their purpose endures. They remind us that we are capable of more than fear, more than survival, that we can choose to seek, to wonder, to reach. Voyager is still out there, a golden echo of Earth, sailing through the whispering darkness.